So yesterday we have seen the derivation of wave equations, right? So we have derived wave equation, and then we have particular case 1, and then we have seen particular case 1 and particular case 2, right? So particular case 1 is when velocity is 0, initial velocity is 0, and particular case 2 is when initial displacement is 0. And then we have solved one problem yesterday. That question is a PYQ, right? PYQ, that is 2000 question. Now we are going to solve some more problems on wave equations, right? So first we are going to solve 2004 problem now. So 2004 problem. So first write down the question. The second problem overall in wave equation. A uniform string, this is 2004. A uniform string of length L held tightly between x is equal to 0 and x is equal to L with no initial displacement. With no initial displacement. And with velocity v0, find the displacement. Find displacement. So this is the problem now. So uniform string of length L is tightly held between two ends, x is equal to 0 and x is equal to L. So it's a string 0 L. Now it is given that initial displacement is 0. So it comes under particular case 2, right? So it is given that initial velocity is v0. In the previous problem, velocity is kx L minus x something. So here the initial velocity is v0. So here our g of x is v0. G of x is v0, which is a constant, right? This is a constant. Now we need to find the displacement, right? So this comes under particular case 2. This comes under particular case 2. And for particular case 2, if we know that if initial displacement is 0, that means f of x will be equal to 0. So therefore what will be our displacement function? Y of x comma t is equal to summation n is equal to 1 to infinity fn sin n pi x by L sin n pi ct by L, right? This is our displacement function. Now we need to find fn. So what is the formula for fn? Fn is equal to 2 by n pi c integral 0 to L g of x sin n pi x by L dx, right? So we have in that when I am giving the notes, I have given for 0 to a. So here 0 to L. So you just replace a to be equal to L. So we need to find fn and then I need to substitute here. That's it. So what is our g of x? G of x is the initial velocity. So initial velocity is given to be v0. So we substitute here. We will have this is equal to, I can take g of x outside because g of x is constant v0. So we take constant. So we have 2 v0 by n pi c integral 0 to L sin n pi x by L dx. So we need to integrate that. That's it, right? So we can integrate straight away because we have only one function of x. So if I do that, this will be 2 v0 by n pi c. So if I integrate this, so integration of sin x is minus cos x, right? So minus cos n pi x by L divided by n pi by L. So this will be, limit will be from 0 to L. So I can take L by n pi outside. So 2 v0 by n pi c into L by n pi. So if I substitute, I can also take minus outside. So if I take upper limit, we will have cos n pi. So if I substitute upper limit, this L and this L will get cancelled. So we have only cos n pi minus. Now if I substitute lower limit, we have 1, right? Because cos 0 is 1. Now this I can write this to be minus 2 V naught L divided by n square pi square c, right, n square pi square c, and this will be minus 1 whole power n minus 1, or else I can also take the reverse term and then I can also neglect minus here. So this will be 2 V naught L divided by n square pi square c into 1 minus 1 whole power n, right. So interchange these two terms, so we have minus outside, this minus and this minus will get cancelled, that is our Fn. So we split this for even and odd, so we have Fn. So when n is equal to 2m, that is when n is equal to even, our Fn will be 0, right, because when n is even, this will be minus 1 power 2n, that will be 1, so 1 minus 1 will be 0, so that will be 0, and when that is f2n is equal to 0, when n is equal to 2m minus 1, that is for odd, this will be minus 2, right, sorry, 1 minus of, that will be 2, right, when n is odd, this term will be 2, because 1 minus of minus 1 will be 2, so this entire term will be 2, so if I multiply here, so we have f2m minus 1 is equal to 4 V naught L divided by n square pi square c. So this is our so I will also replace n to be equal to 2m minus 1, 2m minus 1 whole square. So I'm just replacing the n to be odd, so we have 2m minus 1 whole square n square pi square. This is our Fn. So what will be our displacement function? So we substitute here, we will have, so I can write this term to be, I can only run for odd terms because all even terms are 0. So if I run this for odd terms, so we will be y x comma t is equal to summation m is equal to 1 to infinity. So I am running only for odd terms. So this will be, n will be 2m minus 1. So if n is 2m minus 1, we have 4 V naught L divided by 2m minus 1 square pi square c, and this will be sine, in place of n, 2m minus 1 pi x divided by L, and here again here n is equal to 2m minus 1, so we have n 2m minus 1 pi ct divided by L. This is our displacement function, right, that's it. So we move on to the next problem. This question asked in 15 marks, right, very easy question. If you can do this, if you know the y of x comma t formula and Fn formula. Third problem. There are only 6 to 7 problems in textbook, right? So if they are decided to ask the problem in wave equation, it will be one of the problem from this 6 to 7 questions. That's it. We can assure that we already solved 2 questions. Now we're going to solve another 4 questions now. So 6 questions overall, and I'm going to give one problem for you for exercise. So third problem overall, a string of length L. A string of length L is initially at rest in equilibrium. Is initially at rest in equilibrium. That means initial displacement is 0. And motion is started. And motion is started by giving each of its point a velocity. By giving each of its point a velocity given by velocity will be kx if x is between 0 to 1 by 2 and k L minus x if x is between 0 to L, 0 to L. Find the displacement y of x comma t. Find the displacement y of x comma t. Now here the velocity is given to be, in the previous problem we have velocity to be equal to v naught. So here we have kx from 0 to 1 by 2 and k L minus x from 0 to L, sorry 1 by 2 to 1 by 2 to L. So we need to find the displacement function. So what will be our formula? So first what will be our formula? Y of x comma t is equal to summation n is equal to 1 to infinity fn sin n pi x by a sin n pi ct sin n pi x by L sin n pi ct by L. This is our formula, right? We need to find fn. So what is our fn formula? It is 2 by n pi c integral 0 to L g of x sin n pi x by L dx, right? Sin n pi x by L dx. Now here the g of x is, we have two functions for g of x. This is our g of x, right? Because this is our velocity, and here it is given that initially at rest in equilibrium. That means initial velocity is 0, initial displacement is 0. So this comes under particular case 2. So we have f of x to be equal to 0. So in order to find g of x, so g of x varies 0 to 1 by 2, we have one function for g of x, and 1 by 2 to L we have another function for g of x. So I can split this as 2 by n pi c from when the range is from 0 to 1 by 2, our g of x is kx plus, and when the range is from 1 by 2 to L, our g of x is k into L minus x sin n pi x by L dx. So we have to integrate this, and then we have to substitute here to find fn. So we will mark this equation as 1. So let us consider this integral to be I1. Right? Let us consider this integral to be I1, this to be I2. So we will find I1 and I2, and then we will substitute here. So our I1 is integral 0 to 1 by 2. I can take k outside. So x into sin n pi x by L dx. So we have to integrate this. So if I use integration by parts, we have uv minus integral v du. So u is x, b is integration of this. So integration of this is minus cos n pi x by L into L by n pi. So uv, this is our dv and this is our u. So uv, v is integration of sin n pi x is minus cos, and uv minus integral v du. So our v is minus cos n pi x by L into L by n pi, and our du is dx, right? So uv minus integral v du, so du is dx. So this will be, we have to apply limit also. So limit is from 0 to 1 by 2, and again this is from 0 to 1 by 2. Now if I simplify this, we will have k into, so this will be minus L by n pi, minus L by n pi, and if I substitute the upper limit, we will have 1 by 2. So x is 1 by 2 cos n pi by 2 by L, right? Cos n pi by 2 by L. This is our upper limit. So upper limit is, in place of x, 1 by 2. So 1 by 2 cos n pi 1 by 2 by L minus lower limit will be 0 because we have 0 into something. Now here I can take L by n pi outside, and the integration of cos x is sin x, right? This will be sin n pi x by L into L by n pi. The limit is from 0 to 1 by 2. Limit is from 0 to 1 by 2. So we have this to be equal to, now again if I substitute x is equal to 1 by 2 here, now we will simplify this. So this will be minus KL by 2 n pi cos n pi by 2 L. And here if I substitute the upper limit, lower limit will be 0 here because sin 0 is 0. Now if I substitute the upper limit, we will have plus k L square by n square pi square, right? So multiplying k here, so we have KL, so we have L square n square pi square, and again if I substitute upper limit to be equal to 1 by 2, we have sin n pi by 2 by L. So this is our I1. Now we need to find I2. So I2 is k into L minus x sin n pi x by L. Actually just an integration, that's it. So our I2 is integral 1 by 2 to L k into L minus x, k into L minus x sin n pi x by L dx. So again it is uv minus integral v du. So if I do this, we will have uv. So u is k in, we will take k outside. So uv, so u is L minus x, v is integration of this. So integration of sin n by L x is minus cos n by x by L, and in the here you will have L by n pi minus integral v du. So v du is minus cos n pi x by L into L by n pi into dx. So this will be, so limit is from 1 by 2 to L. Now if I substitute the upper limit, this will be 0 because L minus L is 0. Now to substitute the lower limit, we will have k into L minus 1 by 2, and this will, I can take minus outside also, right? Minus Lk by n pi, minus Lk by n pi, and this will be cos n pi by 2 by L. So this is our simplification of this term. So here we will have k, multiplying k inside, so we will have KL by n pi, KL by n pi, and again you have to integrate this, right? So this will be plus, if you integrate cos x, it will be sin n pi x by L into L by n pi. The limit is from 1 by 2 to L. So we have, this will be minus Lk by n pi, L minus 1 by 2 cos n pi by 2L plus, and if I take here we will have k L square n square pi square, and if I substitute upper limit, it will be 0 because sin n pi is 0. So sin n pi is 0, L will get cancelled. If we substitute lower limit, we will have minus sine n pi by 2 L. So this is our I2. So we have found I1 and I2, right? So we need to add I1 and I2 and then add substitute here, right? Yes. So actually here you have plus, right? Because upper limit is 0 and minus lower limit. So minus this minus and this minus will get plus. So we have plus LK L minus 1 by 2 cos n by 2. So we have found I1 and I2, right? So I need to substitute here, where I need to substitute Fn is equal to 2 by n pi c I1 plus I2, right? This is what our Fn. So I have renamed this to be I1, this to be equal to I2. So I need to substitute. So if I add this, you will have I need to add this, right? I1 and I2. So if I simplify this, I'll give you the answer. You can just work out. I didn't work out this problem. So the answer will be, so just have to integrate this, right? So if I simplify this I1 and I2, you will get the answer to be 4k L square by C n square pi cube sine n pi by 2. This is what you will get the answer Fn, right? You can just work out this. So you just have to add I1 and I2, right? I think I have made some plus or minus error, I think is somewhere. So nothing, you just have to find integral I1 and I2. I1 is nothing but integration by parts. You have to do that, and I2 you have to integration by parts. You have to add that, and you have to multiply 2 pi n pi by c. So you will get this answer, right? 4k L square. So you just take this exercise. So you just have to add I1 and I2. So this will be our Fn will be this is, and when you see when n is even, this will be 0, right? Because this 2 and this 2 will get cancelled. So we have okay somewhat. So I think I made some minus or answer. So if you simplify this, you will get this as an answer, right? This is the answer. So 4k L square by C n square pi cube sin n pi by 2. So again this will be 0 when n is equal to 2m, and when n is odd, this will be 4k L square by C n square pi cube. This will be sin 2m minus 1 pi by 2. So sin 2m minus 1 pi by 2 is nothing but minus 1 whole power m plus 1. So 4k L square by C n square pi cube minus 1 whole power n plus 1. So when the sine of odd pi by 2, it will be minus 1 whole power m plus 1. So this will be the answer, right? F2m minus 1. So substitute in the displacement function y of x comma t, you will get the required answer. So when you simplify I1 and I2, you will get this answer Fn to be 4k L square by C n square pi cube sin n pi by 2. You need to substitute in the displacement function y of x comma t. So we will do two more problems. These two problems are different, right? So when you can see all the function we have seen in terms of x, right? So in the first problem we have kx l minus x. Second problem we have v naught, and in third problem we have a two function combination of x, right? So we have x, you can integrate easily because you're going to have x into something sine. So you can do integration by parts. Now here we are not going to have x in the function. We're going to have some other terms like sine, cos. So if you have sine, cos, you have to follow the method I am doing now. So first we'll look at the problem, right? Fourth problem. It's a very, very important problem. A string of length L, is initially at rest in its equilibrium position. Is initially at rest in the equilibrium position. That means initial displacement is 0. And each of its point the velocity is given by, and each of its point a velocity is given by dou y by dou t at t is equal to 0. That is, initial velocity is given to be v naught sine q pi x by L. Find the 0 less than x is less than n. Find displacement function. This question we can expect this year. Find the displacement function. So there are 6 questions. There are 7 questions in the book. 3 questions they have asked already. So if they ask us to find if they want to ask new question, there is a great chance that this question will come, right? This question and the next question. So it is given that the initial displacement is 0, right? So whenever they give initial at rest in equilibrium position, that means initial displacement is 0. That means our f of x is equal to 0. They are given initial velocity to be equal to v naught sine q pi x by L. Therefore our g of x will be equal to v naught sine q pi x by L. We need to find the displacement function. We need to find the y of x comma t. So here I am going to follow the different technique. So if you take this as g of x, if you integrate this, you will have sine, right? Because our fn is 2 by n pi c, integral 0 to L, g of x sine n pi x by L. So here we are going to have sine cube n pi x by L, sine n pi x by L. So we need to use sine A, sine B formula. The integration will be very long, right? So whenever if you have sine or cos, you have to use the method I am doing now. It's a very easy method. You can also use this method also, but that method involves lots of integration, right? And also there will be so much of short facts you want to know about the integration. So I am following a different method here. So whenever g of x is a function of sine cube or cos, we have to do the method I am following now. So first we need to find y of x comma t is equal to summation n is equal to 1 to infinity fn sine n pi x by L sine n pi ct by L. This is the function we need to find. First we need to find fn. We can also integrate, you know the formula for fn, but I'm not going to do that, right? So what I'm going to do is I'm going to differentiate both sides. I'm going to find fn some other way. I'm going to do now. So differentiate both sides with respect to t. Differentiate with respect to t. So this will be dy by dt. So I'm just naming this as y. Y means y of x comma t. And this will be summation n is equal to 1 to infinity. And fn, this is independent of t. So we have sine n pi x by L. And here if I integrate this, this will be partially, right? Differentiating partially. Dou y by dou t. If I integrate partially only, I can take this term as a constant. So this will be cos n pi ct by L into cos n pi ct by L into n pi c by L, right? So what I'm going to use the condition, put t is equal to 0. I'm trying to bring the initial condition here. So if t is equal to 0. So if t is equal to 0, so this will be, so dou y by dou t at t is equal to 0 is to be v naught V naught sine cube pi x by L is equal to summation n is equal to 1 to infinity, and this will be 1, this whole term will be 1 because when t is equal to 0, cos 0 is 1. So we will have Fn and n pi c by L is constant into sine n pi x by L, right. So we reduce this equation to this, right, V naught. So this will be as it is. So what is our sine cube x formula? It is 3 sin x minus sine 3x by 4. So if I use this formula, we have V naught by 4, 3 sin pi x by L minus sine 3 pi x by L, right. So I have taken the 4 outside. So we have V naught by 4. So sine cube x is 3 sin x minus sine 3x by 4. So taken 4 outside, and this is equal to Fn summation. Okay, we will run this, right. So put n is equal to 1, right. So we will run this summation. If we run this summation, if n is equal to 1, we will have F1 n is equal to 1. So therefore pi c by L sine pi x by L plus, put n is equal to 2. So I am running this summation, right. So F2, this will be 2 pi c by L, 2 pi c by L, and this will be sine 2 pi x by L, 2 pi x by L plus F3, and this will be 3 pi c by L sine 3 pi x by L, and this will go on, right. Now these two are equal, so if I compare, I need to find the values of Fn's, right. So when I compare these two equations, we have sine pi x L, and here we will have sine pi x by L. So I can equate this term and this term, and here we have sine 3 pi x by L, and here we have sine 3 pi x by L, sine 3 pi x by L. I can also equate this term, and all the remaining terms are equal to 0, right, because this term is equal to this term. So here we have only two terms, that is sine pi x by L, sine 3 pi x by L. So that means we can find F1 and F3 from here, and all the terms are 0, F2, F4, F5, F6, F7, F100, all the terms are equal to 0. So we have only the non-zero values for F1 and F3, right. So in general, we are not able to find Fn. In the previous problem, we have for even it will be 0, for odd we will have some non-zero. But here we are going to only have two values for Fn's, that is F1 and F3. So first we will compare this, and then we will find the values for F1 and F3, and then we will substitute here. That's it, right. So we will then only this for F1 and F3. That's it. So we will have only two summations here, because we have only two terms are equal when you compare. So when I equate this, so we will have, so here sin n pi x by L, here sin n pi x by L. So comparing, so here we will have sin n pi x by L. We multiply, we will have 3 V naught by 4 sin n pi x by L, and here is equal to F1 pi c by L, right. This is the first term. And here what is the coefficient for sin 3 pi x by L? Sin 3 pi x by L coefficient is minus V naught by 4, right, minus V naught by 4. So I need to multiply here, so minus V naught by 4. And here what is the coefficient for sin 3 pi x by L? It is F3 sin 3 pi c by L. So what will be my F1? Our F1 is equal to 3L V naught by 4 pi c, right, 3L V naught by 4 pi c. Yes, 3L V naught by 4 pi c. And what will be my F3? F3 will be, so it's not sin, right. So what is the question? Sin 3 pi x by L? 3 pi c by L, 3 pi c by L. So what will be my value of F3? It is minus L into V naught, minus L V naught divided by F3. So 4 into 3 is 12, so 12 pi c. So we have only two non-zero values, that is F1 and F3. So and F2 and F4, F5 all are 0, right? So F2 is equal to 0 and F4, F5, F6 up to Fn all are equal to 0. So we will have only two values. So we will substitute here, right? That's it. So in the previous problem we have found Fn by integrating. Here we are whenever you have sine cos, you can find Fn's by like this method. So what will be my y of x comma t? So we have only F1 and F3, right? So this is our function we need to find. So we just substitute, we just run the summation for n is equal to 1 and n is equal to 3. So n is equal to 1, we will have F1 sine pi x by L sine pi ct by L, n is equal to 1. Now you don't need to run for F2 because F2 is 0. So you put n is equal to 3, we will have F3 sine 3 pi x by L into sine 3 pi ct by L. Now you substitute F1 to be 3L V naught, substitute 3L V naught by 4 pi c, and you substitute F3 to be minus L V naught by 12 pi c. That is the required answer, right? So you can do this very easily. So if I have sine cube or cos cube, you have to do this method, right? Yes. So you have to substitute here, right? So substitute Fn to be 3L V naught by 4 pi c, and substitute F3 to be equal to minus L V naught by 12 pi c. So we'll move on to the next problem. So if you have x, you found F1 by integrating. That is, if our function is in terms of x, that is polynomial. If the function is a polynomial, you can go for integration by parts or by Bernoulli's. If the function involves sine cos, you can also do that better also. You try to do that in your own. It will take very long time. So fifth problem is, with the string of length L, if the string of length L is initially at rest in equilibrium, that is initial displacement is 0, is in equilibrium, and each of its point velocity is given by same question, and each of its point the velocity is given by v naught sine 3 pi x by L cos 2 pi x by L. So in the previous column we have sine cube n pi x by L, right? In the previous column we have sine cube pi x by L. So here we have sine 3 pi x by L cos 2 pi x by L. Find the displacement function. 0 less than x is less than L. Find displacement function. So first we need to find a solution. So we need to find y of x comma t. So it is summation n is equal to 1 to infinity Fn sine n pi x by L sine n pi ct by L. So differentiate both sides with respect to t, right? You have to follow the same procedure. So just have to differentiate this, right? So differentiate with respect to t. Differentiate partially with respect to t. This will be dou y by dou t, and this will be summation n is equal to 1 to infinity, and fn, and this is constant, so sin n pi x by L. So if I differentiate this, it will be cos n pi ct by L into n pi c by L. Now you substitute, put t is equal to 0. So if t is equal to 0, then dou y by dou t at t is equal to 0. This is same as dou y by dou t at t is equal to 0, because it is a velocity, initial velocity. So this will be at t is equal to 0, this will be v naught sin 3 pi x by L cos 2 pi x by L, and this will be summation n is equal to 1 to infinity fn, and this will be 1 because cos 0 is 1. So fn sin n pi c by L sin n pi x by L. So we will run this summation, right? We will run this summation. I am going to use the formula sin a cos b. This will be b naught. So sin a cos b, right? So 2 sin a cos b will be sin a plus b plus sin a minus b. So sin a cos b. So v naught by 2, and sin a plus b plus sin a minus b. So we have sin 5 pi x by L, sin a plus b plus sin a minus b. So we have 3 minus 2. So sin pi x by L. So we have 1 by 2. Here we will run the summation. So if I run the summation for n is equal to 1, we will have f1 yc by L sin pi x by L plus f2 and 2 pi c by L sin 2 pi x by L plus you will have some f3 something, f4 something, and f5 5 pi c by L sin 5 pi x by L, and so on. So when you compare this, you can see here we will have sin 5 pi x by L. That means we will have some non-zero numbers for f5, and here we will have sin pi x by L. So again we will have some non-zero numbers for f1. So here we will have only f1 and f5. In the previous problem we have f1 and f3. So when you comparing, we will find f1 and f3. So comparing, so first we will find f1. So what is the coefficient of sin pi x by L here? It is v naught by 2. So you have to multiply v naught by 2 inside, right? So the coefficient is v naught by 2. And what is the coefficient for sin pi x by L here? It is f1 pi c by L. So that means the value of f1 will be v naught L divided by 2 pi c. Now when you comparing sin 5 pi x by L, so this will be comparison of sin pi x by L, equating the quotient of sin pi x by L. So here we are going to equate the quotient of 5 pi x by L. So we have again v naught by 2 here, and what is the quotient of sin 5 pi x by L here? It is f5 5 pi c by L. That means what is the value of f5? So f5 will be v naught L divided by 10 pi c, right? V naught divided by L, v naught by 2 sin pi x and 5 pi x by L, f5 5 pi c by L. So this will be 10 pi c. So this is the value for fy. So what will be my displacement function? So it is enough to substitute only n is equal to 1 and n is equal to 5, and you have to write that, and f2 and f6 f7 is equal to dot 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 fn n greater than or equal to 6 is equal to 0. So you have to write all the n's are 0 except f1 and fy. So we need to substitute the formula. So this is our formula, right? Y of x comma t. So you have to run this summation. So if you run this summation, you consider only f1 sin pi x by L sin pi pi ct by L plus you can neglect f2, f3, f4 because all are equal to 0. So we will consider fi sin phi pi x by L sin phi pi ct by L. So all the terms will be equal to 0. So you substitute f1 to be equal to v naught L divided by 2 pi c, and then substitute f5 to be equal to v naught L divided by 10 pi c, right? That's it. This is the required answer. So that's it. So we have finished wave equation, right? So I'll give you from 2 or 3 problems for practice. So I have solved 5 problems. There are only 8 problems in the textbook. Right? So if it is decided to ask a problem in wave equation, it has to be one of the problem from the 8 problems we are solving. So 5 problems I have solved. So I'm just going to give the questions for 3 problems now. I want to give the answer also. You just have to integrate. That's it. Right? Integration is the only work for you. And if you know how to do integration by parts, and if substitute upper limit minus lower limit, you will get f hence. That's it. So you want to substitute f1 to be v naught by L2 pi c and f5 to be that value. So tomorrow we will be solving heat equation and then Laplace equation. That is the syllabus completed. So let's give you the questions for the next 3 problems. So this question is asked in 2006, right? So you can do this. The 6th problem, the deflection of the vibrating string of length L is governed by a partial differential equation ytt is equal to c square yx. They are saying that is a wave equation. The initial velocity is 0. The initial velocity is 0. The initial displacement is given by y of x comma 0 is equal to this our g of x. So given g of x to be x by L if 0 is less than x is less than L by 2. I think I have made some mistake in the problem we are writing, right? I1 plus I2. I think the limit is from 0 to L by 2, L by 2 to L. So written 0 to 1 by 2, I think. That is a mistake I have done, I think. Right? So please check out the problem. That is the first problem I have written in the class. I have written the limit to be equal to 0 to 1 by 2, I think. So I will confirm that it is 1 by 2 or L by 2. This one, I don't know whether it's 1 by 2 or L by 2, so I will confirm that. 0 to 1 by 2, L minus x by L, if 1 by 2 is less than x is less than. So I confirm this after I send photo for this problem, right? I don't know whether it's L by 2 or 1 by 2. So I'll confirm that. Find the deflection of this thing. Find the deflection of string, right? I think it is L by 2. 0 to L by 2. L by 2 is less than x is less than L. I will confirm that after the class. So I will give you the answer. So we will get Fn to be 0 for E1 terms and 4L minus 1 whole power m plus 1 divided by C pi cube 2m minus 1 whole cube if n is equal to 2m minus 1. That is, this is the formula for, so this is the answer you will get for odd terms. So 4L minus 1 whole power n. You remember that sin 2m minus 1 pi by 2 is equal to minus 1 whole power m plus 1, right? So you can easily prove this. So if you apply sin a minus b formula, so after applying sin minus b formula, you will arrive at that minus 1 whole power m plus 1. So this is the answer for this problem, and then you can substitute fn in y of x comma t. So seventh problem. The seventh problem is a string of length L. A string of length L as its ends x is equal to 0 and x is equal to L. If it is released from the rest, so first problem we are doing in initial displacement to be equal to 0, initial velocity is a string of length L as its ends x is equal to 0 and L. If it is released from rest, that means initial velocity is 0. Released from rest in the position y is equal to 4 lambda x L minus x whole square divided by L square. Find an expression for displacement of string at any time t. So here our initial velocity is 0. So in the previous 6 problems we have initial displacement to be equal to 0, but here the initial velocity is 0 and they are given the displacement to be, they are given f of x to be equal to 4 lambda x L minus x whole square divided by L square. Now you need to use particular case 1. So you need to find the value for En, right? So what is the formula for En? So En is 2 by L. So you need to find El. Say 2 by L integral 0 to L f of x sin n pi x by L. F of x sin n pi x by L dx. So here for Fn you will have 2 by n pi c. So here you substitute f of x to be equal to 4 lambda x L minus x whole square L square. Now use integration by parts or use Bernoulli's formula. You will find En, right? So the answer for En will be, it will be 0 if n is equal to 2m, and when n is odd we will have 32 lambda divided by 2m minus 1 whole cube into pi cube if n is equal to 2m minus 1. You just have to integrate, that's it, right? So this is the answer for this problem, 7th problem. So I will give you one more problem. It's a very big problem, but you can practice this, right? So I confirm that whether it is L by 2 or 1 by 2, right? So I will just post a question by just denoting the 6th question. So I think it is L by 2, but I will confirm that. So 8th question, last question. So given the answer also, right? We just have to integrate by using the Bernoulli's formula or by integration by parts. So the 8th problem is, if the initial velocity is equal to, so I will give the initial velocity, you find the displacement function, right? Initial velocity is equal to, it's a very big question, h into hx by L. If L is 0 to L, h into 3L minus 2x divided by x. This question will not be asked, but just for your practice I am giving this. It's a very big question. When x is less than 0, L to 2L, and h into x minus 3L divided by L when 2L is less than x is less than 3L. So you have to replace the formula here. Here the string is of length 0 to 3L, right? So in place of A, you have to replace by 3L, right? Because the string length is 3L. So all the problems we have did for 0 to L. So here we are going to have 0 to 3L. String is from 0 to 3L, and from 0 to L we have some one function, and from L to 2L we have another function, from L to 3L we have another function, right? So initial velocity is, and that is our f of x is equal to this function, and the question it is given the initial displacement is 0. Initial displacement is equal to 0, that is our g of x is equal to 0. Now you find En, right? You need to find En and substitute in particular case 1. So particular case 1 I am not going to write, so you just substitute in En. So our En will be 0 to 3L. It is not, it will be 0 to L, it will be 0 to 3L f of x sin n pi x by 3L dx. So it is not L, it is sin n pi x by 3L. Now you split the integral. So you split the integral from 0 to L. So you split the integral 0 to L plus, and for 0 to L our f of x is hx by L, and you split the integral from L to 2L, and you write f of x for this corresponding function into sin n pi x by 3L plus 2L to 3L, and for this our f of x is h into x minus 3L by L into sin n pi x by L. So you put this as I1, I2, I3, you find all the integrals and then add up all this to get the value of our En is 2L by 2 pi, right? 2 by L. So you will have 2 by L outside. So you find I1, I2, I3 and substitute in this here to get the value of En. So I will give the formula answer for En. So 3 problems you are going to do, 5 problems I have done. If you want solution also, I can give you the solution also, detailed solution. That is already in the textbook. In Dysingenia, all the problems are there. You can refer that also. So En is equal to 0 if n is odd. So here it will be 0 for odd, and it will be when n is even, you will have 9h by m square pi square sin 2m pi by 3. This is the answer for En. Now you can substitute this En in y of x comma t to get the required displacement function, right? So that's it. So overall we have 8 problems in a vibrating string or wave equation. So I have solved 5 problems. So you are just going to integrate all the terms and then you are going to arrive at this formula, right? So 3 problems you are going to do. If you have any doubt in 3 problem, you can text in Telegram, or else I'll send the detailed solution in the evening, right? You try, I'll send the evening later, right? So tomorrow we're going to see ET equation, right? ET equation and then some problems, and then Laplace equation and some problem. Syllabus will be completed. So maximum by another 3 days. So today is Monday. So Thursday I'll complete the syllabus, right? So we'll see in the next video tomorrow, right? Thank you.